Hello, everybody. I'm so excited to be here and presenting you my talk. It is such an honor also to be direct after Alex, because my talk has a slight overlapping part because of the build tool. And so it is a good line up here. So my name is Thorsten, as already mentioned. You can find me on various social media platforms. You can reach out to me if you have any questions after the talk or also other things. And I'm a computer scientist and web engineer living in Germany. I have a master's degree and currently working as a full stack web developer. So in this talk, we're going to go over a few things. Let's start with the idea that we have a project. So in this example, we have a Nuxt project, but bear with me, all the other meta frameworks out there like Angular, React, Svelte, and so on. It's just an example. It's the same for you guys. So in our project with Nuxt, we have a little util somewhere. So a kind of a logic that we might also be able to name something, that a logic that we want to extract at some point. And we can do that, of course, by just pulling it out of our project and making it an own repository. Like also, for example, like here, a foobar plugin that we can then plug in through our package.json back into our project and also reuse it in other currently only Nuxt projects as we ripped the code out of our Nuxt. And let's assume we are using some Nuxt internal logic. So currently it is not possible to use it directly with React, Svelte, Angular, and so on. And that is where we want to plug in unplugin from the un.js ecosystem. And with unplugin, we are able to give it a bundle agnostic approach. So unplugin serves as a more or less lane so that we then can use our plugin in esbuild, roll up, roll down, like already Alex touched there, like other build tools. And then we can plug it in projects that are using React, Astro, Vue, Next, Angular, Svelte, and so on and so on. And in this talk, I want to go over all of this. From now, we looked at from the top to the bottom, but we want to scrap it from the bottom to the top again with an example. And the example I brought to you today is that we want to parse glTF files. That is where the 1, 2, 3D part comes in, because glTF files are for representing 3D objects in the web. And inside our plugin, we want to preprocess these files. We want to generate code for it so that it then is type safe. And that is our goal. So let's start from the bottom. What are glTF files? glTF files are, like already mentioned, representations for 3D data. They contain the models, the scenes, materials, and so on. So inside one glTF file, we have everything we need to show a 3D scene. It is the main format used in the web, because of course there are other formats out there like 3MF, STL. I think you heard most of them already. Maybe you have a 3D printer at home, then you're not using glTF files, but other formats. But it's just another kind of representation used for 3D environments. And this glTF file is represented via a JSON object. So on the left side of the screen here, you have an example of a glTF file. And on the right side, you see the object hierarchy that is represented inside the JSON file. So it translates to this hierarchy on the right side. And like you can already see on the left side, there is an object inside the JSON that has most of the time only arrays inside of it. Let's look from the top. So there's a scene somewhere. Scene is an array, and we have many scenes. For example, only here one train scene that maybe, like the name already suggests, contains a train there. And inside our train scene, we have another array for the nodes. And these are only the numbers 0, 1, and 42. These are not like IDs that we can use for referencing the nodes. These are only the indices inside the next array. So if you go down one step inside the nodes array, there is, for example, an array out of objects, one object that is named the train. And this is at position index 0. So inside our scenes, we can always say, okay, there is the node index 0, and we can then look up into the nodes, and like you already see there, because it is not an ID used or an other kind of index, we cannot really get there in fast and find what we need. But this is all over the glTF file. So if we go even further down, also the meshes are only an array. And here's the pantograph. That is the thing on top of the train that gets the electricity for the train. That is a mesh inside here, also index 0. So inside one node, like I can go one step back, we have also the translation to the meshes. And all down to the object hierarchy, there are also images and buffers. These are arrays that can reference external files. Like, for example, the images could be texture files, and the buffers can be like the train model in a bin container wrapped approach for a model. And so now the question remains, how do we load and use this? Because we want to use it in a website. Like my slides here are, you can see it on the top, a website. The slides are open source and the link is at the end of my talk. But because this is a website, we can get the train inside here. So this is inside our train scene, our little train. I can rotate it. I can do other stuff with it, like, okay, there's a plane, for example. I can also show some shadows with it. Okay, we see the shadows have a problem because the lights are not bounding around it. But it's a website. We can play with this scene. How is this rendered, you might ask? At the bottom, of course, there's the GPU of your computer that renders the image at the end and bring it up to your computer screen. On top of that, we use WebGL. WebGL is a very low-level API in the browser. It has a direct GPU integration and is very complex. So working with WebGL is not fun at all, but it is the direct approach, a very low-level approach to talk with your GPU. On top of WebGL, we have Three.js. It's a more high-level framework that is just wrapped around WebGL and simplifies working with all the structures we already saw, like the scenes, the models, the textures, and so on. So just calling a function there will open up the WebGL and do all the magic in WebGL for us. But working in Three.js is not the end of the line. So there are on top also built other libraries, like, for example, in the Vue Nuxt ecosystem, we have Trest.js. In the Svelte ecosystem, we have Threlte. And for React, we have ThreeFiber or Dry as a wrapper around that one for some helper functions. But all of these are wrapping Three.js, and Three.js is wrapping WebGL, and WebGL is talking with the GPU. And so as a developer, you can decide on which level you want to have your application set. You can, of course, write WebGL directly. You can also write Three.js, and you can also write Trest.js. Also, Alvaro is giving a talk later as the founder of Trest.js and the core behind it. So shout out to him, and you should also check out his talk then, because he is maybe showing us some cool tricks and things there. So for our approach, of course, because we want to make it agnostic for also React, Svelte, Angular, Nuxt, and so on, the most high level is not what we are going to use. We want to focus on the Three.js because that is the only thing and the highest thing we can use all in our meta frameworks up on this one. So loading a glTF file in Three.js native can be done like here. Sorry, it's very warm. Stay hydrated. So in Three.js native, we can have the glTF loader. And with the glTF loader, we are able to load a glTF file like it is done in line 6 here. So the train glTF file is loaded. And on success, we then have access to the glTF animations, the glTF scene that is from type 3 group. We have the scenes, the cameras, and so on and so on. But we cannot cross-reference them. So we cannot go inside the scenes and then say, okay, inside the train scene, we have a train, so let's get it. We have to make this on our own. So we have inside our train scene a group of children with the index, and we must use the index to then indices the other arrays. So some problems using with this approach is, for example, that we can only load it at runtime. So in development, we have no view on our glTF file. We do not know what is inside there. Only if we run it, we can see it, because Three.js is heavily depending on our browser API. Another thing is that because we have nothing in dev, we also have no typings. We have no code completion when we write our code. We have no safeguards, because maybe the designer changes the name from train to train 2 or train 3. Then our code will not crash on build, but it goes through the build. Everything is fine. And only when you run in runtime the website, then you can see an error or nothing at all. Also, getting a node, like for example the train, inside the train scene, or the pantograph in this example, is done via a depth-first approach. So if you are very bad luck, then you have to go through all the children, all the graph, and only the last node you're touching is the pantograph, because this get object by name is a depth-first approach for searching inside the tree. Also, models must be in the public assets folder, so you have no versioning control and something like that. And also everything, because there is no versioning, is bundled. Also, if you maybe do not use the glTF file, it will end up inside of your application. So it would be a very cool thing to not use the Three.js native approach, but more of a vision like this one here. This is just pseudocode, but hey, let's say we can import our train glTF file like in line 3. We can then await it like in line 5. And we can use code completion like, hey, the train model dot window left dot something or dot pantograph dot something with a correct typing. So the train model could be of type 3 group. The window left could be a 3 mesh, for example. And you have the code completion, and you can just auto-complete via your IDE. And then you have, of course, no failures again if you want to build it and something from the names changed. So how do we do this inside our plugin? Yeah, the first problem is that Three.js is not for our development. It is for runtime, like already mentioned. It needs the browser API. So the main solution, because we are all developers, is, yeah, we patch it. Just npm patch Three.js. It's just a small library and nothing there. We can do that with many lines of code, but it is possible. But we have to clone 3, because of course later the user needs the real Three.js on runtime in the browser. But in build time, we need a second Three.js that is patched and is able to be used in dev time. Also, now we have Three.js, we can run it inside our node. We have a Three.js in node runner made by patching it on our own. So we can use it to open our glTF files in dev and in build. We do not need to parse glTF files our own, because Three.js is doing that for us. And we get exactly the same representation of the glTF file that we would get later inside of our browser. Because of this Three.js, the glTF loader works the same. It is only patched to work with Node. So then we can pack our types, and by using the names of the children, we can then link the indices to it and store everything, so the whole scene graph with all the children, all the names in a file. And we use handlebars to generate the files. That is just a design decision. And so we generate the bottom 2 files. So the train glTF files on the top, the black ones, are what we already had. And the 2 last things, one for the typing and one with the actual code that is then executed, will be generated by our implementation. And it looks like this. On the one side here, on the left side here, you have the types, and on the right side you have the actual code that can then be run. And you can see here already we just store the names. Like here you have the pantograph, and the pantograph is inside our scene graph at the children position index 0, and they are also children position 0, and so on. Of course, in a real life example, these are not always all zeros, because these are the indices of the children, and they can end up really, really big. Okay, cool. So we had some problems before. Now let's see if we solved our problems and have solutions now. So at first, it was not able to run it in development and build time. We fixed that by patching Three.js, so it can now be used there. Also, we had no typings with no code completion and no safeguards on build. We fixed that. We have now our type files. We have our code completion. We can use all the things we like and love in TypeScript. Also, our depth-first approach for searching is now obsolete because we can directly use train scene.train.roof.pantograph. And because we call it pantograph, we know it's index 0000, and we can just walk inside our graph direct to the node we need and not searching for it anymore. Also, our models are now in the assets folder. We can version it, and we only bundle the models we really use. Great. So that's awesome. From a perspective, from our plugin, we are ready. We want now to make this agnostic for all the build tools. Like already mentioned at the beginning, we therefore use un.js, or we use unplugin from un.js. It is a unified plugin system for build tools. Like Alex said to me once, it is like the jQuery for build tools, and I really liked that phrase. So shout out to Alex at this position, at that point. But that is a good description for this. It is mainly authored by Anthony Fu and Kevin. Also shout out to these two. They are doing an amazing job here. And it supports a huge variety of build tools. Just to name a few of them, this is a screenshot from the current website from today. And like you see, the more on the top, on the bottom right, they have a list of build tools they are supporting. But how do they do this? So here we have the unplugin starter. I just loaded it in so we can have a quick look at it. So only our plugin we programmed is inside this plugin folder inside our source folder. So in the big example I showed you, we want to load glTF files, we want to parse it, we want to do stuff with it. Here the plugin is just a little counter. It's really nothing big. It's just, hey, if we want to insert a new counter, we can click a button and then we can increase the shown count in the end. So that inside our plugin is the plugin we want to program. And all the other files here are for all these build tools. And these are the files that can then insert it in our real life project. So in the playground, normally you do not have a playground inside your unplugin project, but here this is a representation of what your real project could be. And inside our real project, this real project is built up with Vite. We then can say, okay, we want to import our unplugin. It's just called unplugin here because it's unplugin starter. For our example, it would be glTF type toolkit, for example. And then we can plug it under the plugins. And that's it. He is then calling the Vite file out of the source. So this file is then called. And like you can see here, nothing really fancy is done. It's just the unplugin factory that is setting up the Vite environment for us full automatically. Of course, you can change it a little bit, but that's more than enough for most scenarios. And what it does is it also uses the index file here for the options. So you can plug in some options that then end up inside this little options part here. For example, if a user uses your unplugin plugin, you want to specify some special paths or manual options the user should be configuring, then this is done in the index file. And the rest is pure magic. Not really, it's open source. You can go out there and check the code, but it is then building up one repository, one project, where you can then import these different files depending on the build tool you're using. And then the build tool hook is used to call your plugin, and the plugin is then working out of the box for you. So you have then two ways of differentiate between your build tools, because not each build tool is built the same, of course. Maybe in the future, like we heard in the last talk. But currently, you can do it via either in the build tool plugin files. I already showed you the vite.ts, the astro.ts. You can there tweak a little bit the end bundling of your build tools. Or you can, inside of your plugin code, differentiate between the build tools like it is done here. As an example for the esbuild, we want to recognize, are we in the build phase or not? This is what we want to do. So there should be an exported function isBuild, and it should return a Boolean. And we do this with an unplugin factory, and we can then differentiate between, okay, this object here is run when it is esbuild, this is run when it is farm, and so on and so on. You get the idea, so we can then fine-tune and change some logics there. For example, for esbuild, there is no way to detect it at all, so we just fail there, so we cannot see if it is built or not. And for example, for the webpack and the Rspack, we are just calling an external function and give it the compiler. It's an object. We have more information inside the object, and then it can handle this. So we can very fine-tune and see which bundler are we and what do we want to do when this bundler is detected. So when we created the type tool, the typing for the glTF files plugin, we had some challenges, of course. Just to name a few, for example, the esbuild does not allow for some watching in the dev phase. So sometimes you have to restart your whole server because the watching is only working in the build progress. This limits the watcher benefits a little bit. Also, the emit files did not provide a way to receive the generated file names. This was, so our solution for this was just to give the files manual names and force these names. Also, there's no unified way to detect if we are in development or serve or build time, like I showed you in this example. This was a real-life example on the last slide from our code, because we had to program a workaround for this. So in the end, we always have to consider that build tools are different to each other. They are not the same, and unifying them is not easy. So Unplugin is doing a great job, but still it is in development. So if you find a bug, contribute to it, raise the bug, help fixing it maybe. This would be awesome. And this is then the final result. A big shout out also to Andreas Fehn at this point, who made this happen with me. The glTF type toolkit is out on GitHub. You can give it a star and see the code. It is open source. Like, we implemented the glTF parsing and all the stuff around unplugin and all our little hacks and workarounds we did there. And with our plugin, it is very easy to also create very complex scenes in the web, like this little idle browser game we created also, because with our typings, it is very, very easy to just get in this complex scene all the nodes and all the stuff, and we can create an idle game in just like no time a little bit. Okay, so the takeaway for this talk is that it is not magic in the end. You can do it very easy, you can do it today. So if you have a plugin you're maintaining or you're planning to do, just think about maybe using Unplugin and bringing it to a whole new audience at the end of the day. Of course, if your plugin does not rely on the build tools and is only a little counter that is like one addition for two numbers or something like that, so then of course you do not need Unplugin. But when you need the functionalities from your bundler, then Unplugin is a good way to go for giving it to a very large audience at the end of the day. So thanks for your time. This is your moment for making a screenshot to all the sources. The presentation slides are on GitHub, open source. Also, there's a pre-built function that you can look at them in your browser for yourself. All the other links, my social medias are there. If you have any questions, reach out to me. Thanks for your time and for having me.
Hey, thanks for your time, Thorsten. And yeah, it's indeed important to stay hydrated, so good way.
Yeah, it's so warm, summer is coming.
Indeed. We have a few questions. First one would be to know what would be a good actionable step as a front-end developer to do plugins in this way, even if we have no experience with 3D assets?
Sorry, I must read the question, or what's the
Yeah, sure. I'll let you read it.
Okay, so
all the questions are
custom.
like 2 or 3 lines long, so yeah, I can give you some time to read them.
Nah, no problem. I had to just flip the
Sure,
screen
sure.
so I can read it really. Okay, yeah. So as a front-end developer, it is very easy to get Unplugin up and running. You do not need 3D at all. It was just an example. So in the end, if you're building a plugin that relies on your build tools, for example, your Vite, then you can just look out the Unplugin starter that is out there. I saw that Anthony Fu made some changes 2 weeks ago, so that is up to date there. You can just pull it and have a look inside of it. You already saw the code. It really is like 20 files. Each file has like 5 lines or something. It is very easy to get up and running there, and it is very, very powerful. It can get frustrated in the end because the different build tools really have some huge differences at some point. But it is worth getting around it to just get your plugin for more people at the end of the day. But that is what we are here for. We are one community, even though we are using different meta frameworks. But
Yeah,
why building only your framework for Vite and not for the Angular community?
fair. Speaking of challenges, can you make a reference of a few specific that you faced?
We faced a lot of them, so I do not want to talk about the documentation too much because the project is huge and big, and sometimes the documentation does not really align with the actual current code in Unplugin. So that is also something I should point out. If you're working with Unplugin, sometimes looking in the actual source code can save you a lot of time. But in the end, it's a back and forth. So write your tests would be the best example I can give you and the most important thing here, because you cannot just look at it and test like 15 bundlers at the same time. This is really nearly impossible. And in the end, the bundlers that made us the most challenges were farm and esbuild, because they have another kind of focus like Vite does currently have, and therefore it does not support like also basic stuff we are used to out of the Vite ecosystem view.
Yeah, testing sounds like a very healthy solution for any kind of question. I
That is
agree.
true.
Do you have any tips for complex assets when it comes down to TypeScript definitions?
My best approach here would be use our toolkit we made because
Okay.
this helps a lot there. It is fully functioning. We have currently version 1.2 out there, and it can scan really complex assets. Of course, it is also not ready. It is also in production, but getting the types definition really help in your scene, because otherwise you have to go through the get objects by name thing. You have problems bundling and do not know if this is really the dev view versus the production view in the end of the day. So the glTF files were, the version 2 of glTF was released 2017. That is also nearly 8 years ago. And we are developing and going forward in IT and in tech in general. And at some point, maybe this will get adapted. But currently it does not seem like it, so we have to work with these old JSON representations at the moment. Having a tool like this then really helps.
Okay. Yeah. Very nice. Thanks. I also love the fact that I first saw your demo of the 3D scene, and yeah, there's definitely some improvement. So nice
Oh,
to
thank you
see
very
it
much. Yeah,
to
we
see it
talked
more
about it like
powerful.
half a year ago or something like that,
Yeah,
in a very early state
quite
from
some
the
time
idle game.
already. Indeed.
Yeah, yeah. So
Anyway,
thanks for
thanks
having me.
for this creative talk and also a very nice approach for the builders. And I wish you an amazing day. See you
Thanks for
soon.
the nice hosting, Kisu, and have a good day.